Okay, good morning, Bala. Today session is very important session for me because today this first person is my student. I am very proud of my student because the biodata of my student is very high as compared to my biodata. So I am very proud to be a part of our FDP for accepting the FDP. Thank you very much. Now I request Vardhan Shigar to introduce about today's resource person. Right.
Thank you, sir. Sir, we really feel very happy, sir, to see you here and as a student of HM, sir. I am delighted to welcome you all to this session as we have very special guests joining us today. Kindly join me to welcome Dr. B. Hanmantravan. Coming to his academic profile, he has completed his BTech in Electrical Engineering in SKIT, Srikakulam Street, and MTech in NIT Surat, Karnataka, and PhD in NIT Trichy. Since 2009 to 2001, he has worked as assistant professor in Jubilee Department, GPCET, Karnool, assistant professor in Geetham University during the year of 2013 to 2017. From 2021 to 2023, Senior Power System Research Scholar of Electrical and Electronics Engineering. Currently, he is working as an assistant professor in the Department of Electrical and Electronics Engineering, NIT Rourkela, Odisha. He has published the IEEE transactions and other high index journals. In addition to this above, he has presented several papers at various national and international conferences. Without further ado, I am extending my warm welcome to Dr. Hanmantravan sir.
What is there for another lecture?
Sorry, sir.
Awards. Okay, he got the several awards from repeated forms. That is the great assessment of today resource person. Okay.
Thank you, sir.
One second, one second. Camera nanti di convert. Ini kalau convert mana kan bisa. Langsung launching.
Artists do this.
Yes, sir. Yes. Thank you for inviting me. I'm feeling very honored to be coming here and giving my talk on my research topic. I'll be presenting part of my research topic. Thanks to HOD sir. And today I'm feeling very much happy and not nostalgic feeling because I'm having another professor who taught us during my PhD. Today we'll be discussing about energy management strategies. One of the strategies will be monitoring, another strategy will be setting down. I'll go at a very slow pace. I don't want to dump a lot of information. I'll be giving what is dump all the information in my communication. I'll be giving what is what. The topic is energy management strategies in smart cities. These are the content that I'm going to cover in my presentation. Okay, what is energy management strategies and responsibility? Okay, so in the morning session I will be discussing about the demand response strategies. And in the second half I will be discussing about transactional energy or peer-to-peer energy. What is basically a smart city? What is basically a smart city? Before going to dive into it, how many smart cities we are having in our knowledge? Anybody is from smart city or under? We are having everybody is not smart city. Kerala is another smart city. Amaravati is a smart city. And Tamil Nadu is four smart cities. How smart they are? You know. God only knows how smart they are. Anybody is from Vishal who knows about what kind of smartness we should observe, sir?
In highways, we have solar platforms and smart automations.
Automation in
Traffic lights. In Mitchell also we can see the solar street lights. Apart from that, we have solar floating plants in Musalwala.
okay.
And many renewable energy sources like rooftop and many of them are generating.
Anybody else from another city, another smart city? What kind of smartness do you observe? So I'm not very good. I do not observe any smartness from anyway, we will not have to look at the smart city. City with the smartness or an it's a smart city. Let's simple. Now, what is the smartness? How we can make the city in a smart city by adopting intelligence? How we can get the knowledge? Using some digital technologies which are implemented in every department and they are integrated for the seamless development. That is a smart city. Okay, you can see the figure. Maybe this one completely getting too much information, but you see that all the departments are permanently interconnected for a seamless development. Okay, so I'll give an example for a city and a small city. Okay, so we know about the small city. We take an example of science. Take an example of healthcare. You're not health. You go to hospital. Doctor will, do the preliminary diagnosis by touching your hand or something. And we will prescribe things or test for the scan for your. We will rush to a scanning center. like a simulator or yes, that is system. And then you have to do all the scanning. You get a bunch of it. You have to put in trust for hospital and you need the only prescribe some medicines. Most of the time they are available in the hospital. Okay, which is run by his own brother or someone else. Okay, and that too, you can split these, understand why only that fellow is living in pharmacy. Nobody else will understand. Let's say if the medicines are not available, he may say that, okay, you come tomorrow, or come at some other point. You have to go back to your home and you are again come back to the medical pharmacy center and take the medicine. Okay, and if at all you are not happy with your diagnosis and your health is not you want to evaluate, then what you go to the hospital to process the reports. And again you will get a monthly. Since there also you are not happy, your financial development report to 600, process 600. And at the end of the month, you will have these many. Okay? This is the healthcare industry. Now take an example of a smart city. City is an intelligence in the healthcare. Okay, but city's intelligence is brought to digital technology. So what are those digital technologies? ICT, IoT, blockchain, digital. So many digital. Nowadays, we are we are bombarded with different technologies. In every field. So let us put it back to intelligence software system. The healthcare is having intelligence software system. Okay. And how it is operated at the smartness in the healthcare system. So I had an opportunity to stay sometime in Ireland. Ireland is the government capital city. Their healthcare is pretty smart. In general, after getting the number to visit a doctor, doctor will see you. No, he will do the preliminary and he will make a report. Okay, and he will tell you same process is same. But only the thing is everything is there in the digital form. You do something, you suggest some scanning, blah blah blah, that is something in the software. And we'll be going to some other place, same building, or the nearest building. There, the scanning person will do all the balances. And that report will not be written. It is directly, will be sent to the doctor. Doctor will have a primary key, like normal. Every person will have a primary key, and the doctors will have a primary key. That report will be directly connected to the doctor. And you will go back to the doctor, doctor will see the report, the scanning reports of the blood test. And he will prescribe something. That medicine he will not get, hard copy. That he will transfer to the pharmacy. And you go to the pharmacy, just tell your primary your name or whatever. And they will give you the medicines. Let's say some of the medicines are not available. They can tell you to come tomorrow, not a possibility. Or they will ask you, where are you from? Let's say I'm just so much so. They will check what is the nearest pharmacy. They will direct the prescription to that. And you go home, take the medicine. Okay, let's say it is not available, you will process. Here, there is no digital copy, hard copy. Everything is in the digital format. You can observe the smartness, the kind of smartness in the healthcare. It is there in every sector. The city with such kind of smartness is called smart city. Or we are talking about only one department. Let us connect two departments together. Okay, I'll give an example. There I see I will give a disclaimer that I will be comparing city in India and city in Ireland. It is not that I am cheerleading only the Ireland or the European country. I had a privilege that I saw. I'm just giving an example. It's not that we can criticize our own country. We need to pay, subsidized education from India. I'm working for a government as well. I don't want to criticize my government or my country. I'm just giving an example to compare city and small city. Okay, take an example of agriculture. What I observed. Okay, I'll give you example the city and a small city. In agriculture, like how the farmer he is the man. He can decide what crop he wants to cultivate. It is up to him. How much pesticides he want to put, he can do. This person who is eating the vegetables, we don't know what kind of pesticides. Okay, he has all the incentive to use anything. The person who is selling, he has all the incentive to buy whatever the company. Nobody knows about the company. What kind of chemicals they are using, nobody knows. What kind of chemicals they are using, nobody knows. So take an example of that farmer. He wants to, cultivate potatoes or something, the agriculture. So he is cultivating. Now the government are giving subsidies for the energy meter of agriculture. He is getting subsidies from the government by different means. In terms of the insurance of crop, in terms of the smart meters and such as the agriculture. The government doesn't really control over its decision on what kind of crop he has to cultivate. The person who is cultivating that he is the monopoly. You can decide whatever you want. That is there in a city. Now take an example of smart city. This I have observed because W is very processing. I should give process of the city where I can see farms. But I observed that they have peace of mind. Say the person is deciding, the person will not decide. The government will decide. Government will do the soil test. There has sensors in soil. That data is pushed to the cloud and satellite is observing with an immense process. What is cultivating? The government knows what you are cultivating. The government will tell you if you cultivate corn or potato, you will give this much subsidy in terms of reduction in your energy bill or in terms of insurance. Whatever you are getting subsidy, if you don't want to give a subsidy, follow my instructions. The government decides. Okay, let's say that fellow, after cultivating one season, there's another season. How he decided he wants to do only for that? Okay. Because in the market, let's say, price of potato is more than corn. The government is saying don't go for potato. Don't cultivate potato, cultivate corn. Because like every day it has to change. In order to protect the soil. The government, scientists are to go with another crop. But this fellow, we don't want to listen. I will put potato. No government will come and check here. But there, the government will not come. But the satellite is capturing the image. The sensors are transferring the data to the cloud. And they observe the data is in this data system. And it is not only the person also. Government is saying, this person is also saying, and you will not get any such. It is as simple as that. It is like analyzing the person who is violating the rules of the government. This, it is no person is involved. It is an automatic process in the digital system. So this is a smart principle agreement. Here if you take, it is not only the agriculture department is connected, the electricity department also. He is not getting subsidy from the electricity department. He will be penalized for the energy consumption also because he is not, he violated the rules. Okay, so how the electricity department knows about this agriculture? Because both the departments are interconnected. They are in the digital cloud. So here the data is transferred from one sector to another sector seamlessly. This is happening, this is not happening in a city. But this is all happening in a small city. Let's say this farmer, he wants to take a loan from a bank. He goes to the bank, but he will not get it. The bank people also know that this one is what it is. He will not get it. So now the finance sector is also knowing what you are doing. So every sector is interconnected. They are transmitting the data seamlessly. They know the data. You cannot escape. Let's say if I committed a crime or something, if I did not pay my rent for 2 months, every department. Let's say I want to move out from the other and get for the Okay, so this is an intelligence system where all the departments are connected. So now what is a smart city? City with an intelligence. The intelligence is with the digital technologies. Okay, so whatever I told you. Here you can see. So now you can observe that what is a smart city. Smart city is a city where multiple departments, governing bodies, all the departments are interconnected by a digital platform for serious data transfer and improve standard living of the person who is living in our community or even in the agriculture or in the rural areas. You can take example, so many departments are there. And there was a joke long time ago. If a person is keep on eating pizza, okay? So if we are in the smart city, let's say you go to the restaurant, if you order pizza, then you will not get a pizza. because you are bad, immediately the data will be, since your data, your primary key to be simple, you are waiting a pizza for a long time, you will not get a pizza, or you will not get a biryani this time, because your body is not contact with so many pizzas. Okay, so there was a job long time ago, but this will happen soon in India also. It is happening in abroad. Okay, so you are under the surveillance of the government or under the surveillance of the digital systems. Okay, so that's one of the smart city in a simple sense. Understood? Now, the solutions for smart city. Take any department, whether it is agriculture, healthcare, finance, marketing, there are any number of solutions for smart cities. A person, a blogging person, who is looking out of the government, he can check, they can design the different logics or strategies making a city is smart city. And I think it is not really visible. Take a transportation system. Okay, it is a digital system. Now we go to the bus, let's say you are not taking any ticket, you will be penalized. Okay, in the digital system. It is a smart city, everything is a digital system. So one time I did not take a ticket, me my bike was to the bus station, and I got the letter from the government saying that you have to pay 100 euros. So these are all, significant intelligence in every sector that is transferring the data from one department to another department. So that is the smart. Now, what are the features of smart city? As I told you earlier, you can do it by one to simplify the style. A city with intelligent transport system, a city with an intelligent waste management, a city with intelligent energy management, a city with intelligence in every department. In order to improve the standard living of person living in a community. What is it? Okay. So finally, what do we achieve? So we achieve living standard will improve. Otherwise, we have to, depend on what the person is doing in the community. Okay, every time you trust a person, you will be seeking for something. Third person will have. The third person will share your own. So in a small city, you don't want to depend on anyone. Say you want to take a 20 place or figure out this. So now I think it's easier. Olden days you have to rush, rush to do quickly. Then you have to keep on track what is happening, where my file is, and you have to drive it. Then you will get a now I think it's easier. Okay, so these are the features of smart city. Next one, applications and examples of the smart city. As I told you, effective energy management, effective waste management, effective transportation, effective intelligence in every department. Now we are concerned about only as an electrical engineer, we are concerned about only I think something are very expensive, and I am getting this questions. So, as an electrical engineer, so we worried about only energy systems. Okay. So one of the application for the future of the smart city is intelligent energy management. Now we will dig more into our energy management system. So what is energy? What is energy? Why we need to manage it? How we will manage it? Energy is a capacity to be stored long time in our system. Energy is a capacity to be stored over. It cannot be created or destroyed only in transformer and we have electrical energy, you can create a little machine, you can create heat energy, you can create mechanical energy. 90% of the electrical energy is related to drive mechanical energy. 5% or 10% is for the illumination and temperature control. Okay. So now, what is this smart energy management? The simple thing, energy management is a strategy to adjust or to readjust or optimize it. Basically, energy management, how strategically you will, manipulate or how strategically you will adjust the demand so that your energy consumption will reduce. Okay, so now who takes care of this energy management? Energy management system takes care of this energy management. Okay, you can design n number of energy management strategies. It is up to the person who is handling, or the person who is handling the energy management system in their residential or micro level. Okay, now what is the objective of energy management system? That can be understood with the help of the following question. So what is the objective of energy management system? Basically, energy management system address how you are consuming energy, where you are consuming energy. No? Okay, how you are consuming, where you are consuming, when you are consuming. Okay, and you have to address all this. If you can address all these questions, then you are able to design an energy management system. Okay. So next, the future trends of energy management is smart. There, as I told you, there are n number of strategies to design the energy management system. These are the sum of the strategies for energy management system. I will give it one more. You can read it. So it is not only the single energy management strategy, it can be a combination of 2 or 3. Okay, so you can see that this one or even advanced infrastructure, integration. They are all the part of energy management strategy. It's not like okay, renewable energy integration is an energy management strategy. No, it is a part of energy management strategy. If you are having a renewable integration, how effectively you manage the renewable? How effectively you will be managing the load so that your energy consumption will be reduced. These are all the different energy management strategies with some digital technologies. You can see this is the latest one. Very recently I have encountered that digital twins are used for the management. Very few papers are there in energy management using digital twins. Very recently, even I heard the name very nice data, but I read an article about how we can manage energy using the digital. This is something new for me. Okay, so today we will be discussing about how the demand response, dynamic pricing, blockchain. These two strategies are part of my research. So in the morning we will be discussing about the demand response strategy of energy management. The second half we will be discussing about P2P energy trading, strategy of energy management. But there are elements. It is not limited to only this. There are elements of strategies. So we will be discussing now about the simple, and significant components of energy management strategies. First one is smart. What is smart? As we discussed about the smart city. Grid with an intelligence is smart. City with an intelligence is smart. Grid with an intelligence is smart. Now the intelligence is designed by using the digital technologies. There are so many digital technologies. So there is no unique definition for the smart grid. But according to the Department of Atomic Energy by the USA, so the smart grid they define something like this. The smart grid uses the digital technology from generation to transmission to distribution in order to improve the efficiency and reliability and security of the existing grid. So this is a definition by the US. India has a different definition, but more or less it is same. Grid with an intelligence is called smart. You can see so many components are connected. We don't disrupt the existing grid, we will brought the intelligence to the existing grid that makes the existing grid here small. Okay, and another important component of the smart grid is smart meter. What is the smart grid? As we discussed, the meter with an intelligence is called smart meter. There are so many types of smart meters. And before we heard about the smart meter, there is a meter. In older days, we used to have electromechanical meters. What it does, just simply record the cumulative energy consumption of a particular consumer. Okay, and a person used to come to your house to give you monthly bill or bi-monthly bill. Okay, so and that they are replaced with gross meters, and they are replaced with the net meters. Nowadays, we are hearing about smart meters. Just 2 days ago, I read an article about Andhra Pradesh, especially the SPDC, which is going on with smart meter installations. Okay, so very soon we will see the smart meters in every country. Okay, that is a smart meter. And what this smart meter does? Smart meter. Basically, smart meter is also dynamic. Now, I will give a simple example. Older days we are having electromechanical meter, just a meter. we call it as a meter, energy meter. That records the immediate energy consumption. So now then we got about the gross meter. Now what is this gross meter? A person who is consuming the energy is a consumer. Okay, after a while, during the mid 90s, some of the people they started installing their rooftop solars for their home purpose. Let's say you are going with a high installation, high capacity. You have an excess energy. What do you do with that? You have to feed it to the grid. Okay, now how will you measure how much you are consuming, how much you are feeding? So they started measuring this with the gross meter. Then the net meter concept came in. Now what is this net meter? We have a consumption, we have an appliances, we have a solar or windmill. Okay, and you are consuming from the solar also. There is a meter that measures the net demand, means demand minus generation. Very simple. The net meter measures the net demand of the particular consumer. That is net demand means demand minus generation. So the net meter will measure the net demand. Now there is a smart meter. What it does, it measures everything in code. What is the voltage? What is the current drawn by the consumer? What is the reactive power injection or the drawn by the load? What is the reactive power, real power? It measures everything, including frequency. Or whatever the parameters are there, frequency, voltage, current, real power, reactive power, and you know the load power factor. Everything you can measure in real time and transmit the data to the service provider. At the same time, it will transmit the data to the consumer as well. You will be having an application in your mobile. You can track how much energy you are consuming. Let's say, I will give you an example. Let's say you are having a very good smart meter at your home. Now, while sitting in your office, you can track whether someone is taking a bath or not, whether he switched off his geyser or not. You can track it, and you can remotely control. You can switch it off very easily. So these are the applications of smart meters and intelligence management system, especially for home management systems. Okay, so I think I answered the question. Okay, now what are the smart features of smart meter? As I told you, it will record all the electrical parameters in real time, and it will push the data to the digital, and it will be sent to the service provider as well as to the consumer. These are some of the features of smart meter. What do we do with it? What is the advantages of installing a smart meter for the consumer, and what are the advantages for the utility company? The consumer can take informed or intelligent decisions if you know your energy consumption. You can intelligently control your demand so that your monthly or bi-monthly energy bill will reduce. Okay, you can take informed decisions. And what the utility can do? Utility can plan the tariff structures, and utility can observe which locality is taking more demand, and utility can forecast what will be the future demand. Accordingly, they can plan the generation and the distribution system. They can plan, forecast, design the tariff structures. I think you will read all those. Okay, so these are all the advantages of the smart meters. So this is the hardware prototype of a smart meter. It was designed by my labmate. His name is Shashank. He has designed this the prototype of smart meter. He got the patent also. If you are interested to read, I invite you to read this book. So next component is AMI. What is this AMI? Advanced Meter Infrastructure. We know smart meters. There are so many smart meters at every home. Okay, and these smart meters are transmitting the data in real time. How many smart meters will be there in a locality? How many meters will be there in a city? It is difficult to manage this data. You need communication infrastructure to manage this data for different applications. Okay, so AMI takes care of that. AMI is basically communication infrastructure, advanced metering infrastructure. It takes care of all the smart meter data. To see this figure, you can imagine that there is a residential locality. Each consumer is having a smart meter. They are all able to use smart meters, and where is the data? Where it is going? Let's say I am having a smart meter. You are having a smart meter. Where this data is going? It will go to the data collector, non-significant aggregate, which is there in the corner of your locality. Okay, it will collect all the smart meters data from that particular locality. And use what kind of communication it uses? It uses the home, inside the home is home area network. This network area network. Okay, now the regulator is collecting all the data from all the smart meters, and this will push the data to meter data management system. So this is a data center. Nowadays you are hearing, government is inviting the Microsoft or some big global companies. We are establishing a very data center. Now we don't have a data center. Then now they have a data center. What they are doing is, one of the applications is this. They are, let's say Google, they are building a data center. So that takes care of handling all this computer data. For what purpose? Let's see here. This is a data management system. This is a data management system. This is the customer information system. And of course, you need to provide a security also. And this is one of the application of the data. It is for billing, automatic, billing system. So nowadays, how we are, paying the bills. The person is coming to our home, he is giving, the bill. Most of the time, we don't care about how much energy I consume. What is the bill? If you are intelligent, you will observe, your meter reading. Whether this bill is correct or not. He has all the incentive to temper the data. He can increase his limit, he can increase the limit. He can increase the number of units, and most of the times not use. And most of the times we will pay. Okay. So if you have this AMI, the AMI will record the real-time data at the end of the month, at the end of the month. So it will be automatically detected from your account. Okay, you may not take this. So this is highly secure, and in fact, we got about cyber security. This is also all about the cyber security. You have to design intelligently so that it will be prone to attacks. We heard about so many attacks in the small world. Now recently, Ukrainian war is going on. They are also attacking on the Ukrainian grids. We are getting so many Iranian grids, attack on Iranian grids, and now attacking UK grids, attack on US grids. We heard about so many cyber security issues. Okay, we have to effectively and intelligently design this communication infrastructure so that we can effectively manage all the smart meter data. Okay. So now, what are the benefits of this? You can read that the consumer will have different benefits. Utility will have different benefits. Okay, as I told you, utility can plan, forecast, and they can design the different tariff structures. So right now we are having a flat rate tariff, or block rate tariff. Okay, we consume some X amount at the end of the month, and there is volume mixed multiplied by the and block rate. They will take a demand charge. Very soon you will see the dynamic, tariffs or time of rate tariff, TOD or TOD tariff. There are different tariff structures. Utility can plan based on they will be observing what is the demand of the locality of the city. Accordingly, they can plan. Okay, these are the benefits of plan. So this is one of the AMI designed by my lab, at the same by Shashank. He has designed the prototype of AMI analytics. So if you are interested, then you have to read this. So next component is renewable energy integration. Now this is kind of a buzzword in electrical engineering. Everybody is working on renewable integration. Of course, it's a big umbrella. People are working in one industry. What is this renewable energy? To start from early 90s, we are consumers. Respect to utility, we are the consumers. We are not, customers. Respect to utility point of view, we are the consumers. Consumer doesn't have a choice. Customer will have a choice. We go to a mall. We have so many choices to buy. Nobody is forcing. Okay, you can have a choice which is unrestricted. But when it comes to energy, when it comes to energy, we are consumers. We will have a choice. But in a futuristic scenario, we will become customers. We will have a choice to pick up different service providers. In Ireland, when I was there, I changed two, three different distribution companies. Network is same, only the company will change. The smart meter will be mapped to the A company. Let's say you are not satisfied, your bill is too much. You will be, like a mobile phone. You are not happy with the bill, you can switch to other. Okay, you are not changing your mobile number, you are not changing the SIM card, you are not changing anything. Only the service provider is changing. This is happening in foreign countries, but it is not happening in India because we know how our governments work. And it is difficult. So much population is difficult. But it will come, eventually it will come. We will have a choice to pick up the different, utility companies. Okay. So I was, so in olden days we were the consumers. Now slowly we are transforming into prosumers with the help of renewable integration. Okay, but this renewable energy is intermittent unit. Okay, so we don't get power from the sun. Whenever the sun is not available, when the solar radiation is there, we can generate a power. Okay, when wind blows, we can get a power from the windmills. It is highly intermittent unit. It depends upon the seasons, the temperature, and the wind velocity. Okay, let's say as the time progresses from 90s to 80s, okay, slowly, people are increasing their living standards. They are going with their renewable energy. Now, slowly, the renewable integration is increasing. It is difficult for the service provider or a utility company to manage this, different DVRs. There are not I will be calling it as a DVRs, distributed energy resources. There are different names, RER, PER, renewable, okay, whatever. Okay, I will use the names also. Okay, so I think you got about renewable integration. So this is not the important component of energy management. And with this, what do we get? Utility also get benefit, and the consumer is also getting benefit. So in your home, you are having solar and wind. Your energy consumption will automatically decrease. Your cost is reduced. And what is the advantage of the utility? Peak demand on the system will reduce. Very simple. You are not depending on grid. Your grid reliance is decreasing. Okay, and the cost will decrease. So from this figure, what the takeaway is, if you go with the renewable integration, your cost is decreasing. But there are so many problems also. If everybody started, installing solar and wind, what happens to the system? The network will get congested. Everybody is facing problems. The grid will get congested, and that becomes, difficult for the distribution system operator or an independent operator to handle so many renewables. This is another big problem. So many people are working on this. So now we will smart home, smart residential. What is smart residential? As I told you earlier, we were discussing about smart meter, smart city. Okay. Smart home is a home with an intelligent home energy management system. Okay. So if you see this figure, a smart home is equipped with a smart meter. A smart home is equipped with renewable energies. Okay, smart home is having battery energy storage system and different household appliances and energy management system and having an interface, and it is connected with a home area network, and it is smart meter is able to connect with other meters of the data office. So yeah, quite a different. Okay, so that is the smart. A home with so many appliances and renewables and battery energy storage systems and tanks is known as smart. Okay, according to different researchers, they have classified the different household loads into types. Okay, so all the household appliances are classified into two types. One is schedulable loads or flexible loads. Another one is non-flexible loads or non-schedulable loads. What are the schedulable loads? Schedulable loads are the loads you can shift from one unit to another. Non-schedulable loads you can shift from one unit. What are those examples? Let's say you are having a washing machine. You wanted to schedule it by the end of 8 a.m. By 8 a.m. my wash will be, my clothes will be washed. My dishwasher should finish its job by 8 a.m. You cannot shift that to middle of the day. You cannot shift it to summer. You are having a fan. Whenever you want to have a fan, you cannot shift it and you are having a refrigerator, it needs power 24/7. Okay, some loads you cannot shift, some loads you can shift. So they are classified as schedulable and non-schedulable load, which are further divided into interruptible loads and non-interruptible loads. Best example is, so you are having a dishwasher and you are having a washing machine. The moment you stop, you cannot interrupt. Let's say a washing machine needs 2 hours of stop. You cannot interrupt it. So that is a non-interruptible, non-schedulable. Yes. Or you can make it schedulable. You can schedule between 6 to 8 within that period you can schedule. Okay, and let's say you are having 12 you can schedule it. And you can interrupt it. Let's say I wanted to, turn on the bell on morning 6 a.m. Let's say quarter of the time is good. You can, interrupt it and you can reschedule it to the 11 a.m. Or you can interrupt that and you can reschedule it to some other time. So this is interruptible schedulable. Okay. So according to group of articles, okay. So it is not won't be classified here. It is already there in the literature. Okay. So we are classifying the entire household loads into two groups: schedulable, non-schedulable. They are further divided into interruptible loads and non-interruptible loads. So and together is a smart home. So if you want more about smart home, I invite you to read this.
LED smart cities.
Sorry.
Regarding LED smart cities.
Yeah, if you read the whole paper, you will understand. So,
New journal. LED smart city.
sorry.
LED smart cities journal. Is new journal or old journal?
This is relatively new, not old.
Open access.
18 or 18.
Open access. Open access.
Now it is open access. And it was not. It was not. I published it without taking it. All my publication 0 MPC.
Directly you can download it.
You can download. Okay, so next one is another component is consumer. We know consumer. We are having appliances, we don't have a renewables. The person with appliance is known as consumer. The person with a lot of appliances and home energy management system and renewables is becoming prosumer. Now, what is this prosumer? It not only consumes the electrical energy but also produces energy. It depends upon the intermittent nature of the renewables. Okay. So now the consumers are increasing. It is becoming very difficult to handle so many consumers. Handling so many consumers is nothing but handling so many areas, handling so many renewable energies. Now this has become a critical task for the utility service provider. Okay, now how they will manage this so many people? How do they manage? Now they should intelligently design the system so that you can manage the energy effectively. So now that's where energy management system will be pictured from the utility point of view. Okay, from the consumer point of view, we will slowly discuss. Now we are seeing from the utility point of view. So many TVs, so many variables are there. I need to manage it. Then I should come up with an intelligent energy management system in a particular locality or in a city or wherever the service provider. So now they come up with different energy management strategies. Some of them are demand side management, demand response, transaction. We will be discussing about the last one. What is this demand side management? The load on the demand, the load on the power system network is an unknown variable. It will vary from time to time. Okay, and you cannot tell the consumer, oh, switch off your AC. The person who is sitting at the distribution system operator, you cannot tell the consumer, switch off your AC. And the loads are keep on increasing. So what utility should do? They have to control the generation only. Based on the demand, they have to control the generation. So there's no other way. I'm talking about general, in a grid point. Now with an intelligence, what we can do? We can come up with a different energy management strategy so that we can control the consumer also. How? That we will be discussing soon. Okay, so this demand side management, instead of controlling the generation, why can't we control, why can't we manage at the demand side? That's where this topic will be. So we are managing the demand at the load setting. Instead of managing only at the generation, we are managing the demand at the demand side. That's why the name, the demand side management capability. So this is not something new. I heard this name a decade ago. Okay, so what is demand side management? And demand response is also another energy management strategy. Transactional energy is also another, demand. These two are subset of demand side management. We will discuss it. So, what is this demand side management? As I told you, now you are able to understand what the problem is. Perspective point of view. There are so many renewables. I need to control these renewables. How I can control? And I need to manage those DERs effectively so that I can maintain the real-time balance between the demand and demand. Okay. So demand side management is a technique or strategy adopted by the utility so to adjust or to optimize the energy consumption factor. So that's a demand side management. Now the response from the consumers in response to the utility actions is nothing but demand response. The transactional energy is an extended form of demand response. What is transactional energy? We will see after a few minutes. Okay, are you able to follow me? So this each topic is a research topic. Okay, demand side management is a strategy adopted by the utility to manage the demands. Okay, demand response is a response from the consumers in response to the utility actions. Transactional energy is an extended form of demand response. It is gaining the popularity very recently. In 2017, I joined my PhD. My supervisor gave me this keyword. Hanuman, you are going to work on transactional energy. I don't know what is transactional. First time I heard about transaction we heard. What is this transactional energy? I don't know. I went and searched transactional energy papers in IIT. At that time I got only 5 papers. One activity transaction power system and few others. I got only 5 on the transaction. Now if you search transactional energy, more than 5 lakh papers are there. So people are working from every corner of the world. But this is still buzzword. Transactional energy is still buzzword. Demand response is pretty good. I'm going to come back. So I hope you got the meaning of each component of energy management strategy. So now what I do is in the morning session I will be discussing about only the demand response strategy. Slowly we will move towards the transaction. Okay. So I will be discussing about one of the demand response strategy. So this is one energy management strategy under the umbrella of demand response. There is no only one particular strategy. It is up to you how to design the strategy so that you will maintain the real-time balance between demand and demand. Utility concern is only I need to maintain the balance between the demand and demand. Consumer objective is different. Utility objective is different. Utility objective is somehow I need to maintain the balance between demand and demand. Consumer objective is I don't care. I need to optimize my energy. My energy consumption bill should be as minimum as possible. That is my concern. Utility, it is no. Their objective is something like government. They have multiple, they have think about it in multiple directions. Okay, so then the utility came up with this idea called maximum consumption limit or maximum demand limit. A simple example I will give you. Now, if you consume 1 unit of energy, let's say from 6 to 7. The price is same. If you consume the same unit from 11 to 12, the price is same. Okay, so what I will say, the price is constant for the day. Okay, it doesn't matter how much energy you consume 4 units, 1 unit, 10 units, 100 units. The price is same in that particular hour. When throughout the day is same. So now then the utility, came up with this idea. Let us impose a penalty on the people who consume more than the consumption. Let us say if you consume more than 4 units in an hour, you will be penalized on. So this is, this new strategy to control the demand. Okay, to control the demand. Even if the consumer is there, still you can control his demand. Okay, so bottom line, this is the simplest ABC of demand response. This is the simplest one. If you consume more than certain units, you will be penalized. Before that, you will not be penalized. Okay, so I don't want to read this, but I think we got the essence. Okay, now how do you design this strategy? Mathematically, how do you design? So this is an ATAL. Your energy bill for a time margin. The time margin could be a day or a month or it could be. Let us imagine that it is for 1 day. Okay. So it depends on, it is having two components. One is energy cost plus penalty cost. Energy cost is how much demand you consume. I have written ND. ND is for both the consumers and prosumers. If you are a consumer, you will have only demand here. If you are a prosumer, you will have net demand here. Net demand multiplied by the energy price. It can be a constant value or it can be a time varying value. Right now we are having a flat rate. In the future we will have a time varying price. It will vary from time to time. Utility can take one decision. Okay, so they can come up with any unit tariff structures. So now what is the second component? Is the penalty cost. If you see this, if you go beyond NC, you will be penalized with some price, penalty price. Okay, and if it is below the LCA, you are not penalized. This is a simple strategy, so that the utility is imposing certain rule on you, so that you will not cross above the LCA or MDA. So you will be controlling your demand below that in order to reduce your energy cost. Okay? So if you want to take more, I invite you to read this paper. This is my course for. Okay. So now coming to the consumer, how you will do this? As I told you, the entire household appliances are classified into two types. They are further divided into two types. Schedulable, non-schedulable. They are further divided into interruptible and non-interruptible. Examples you can see. So non-interruptible, non-schedulable loads are live, span, freezing, values. Whenever you want to consume, whenever you turn on, you need a power unit. They are the critical loads. They call it as a critical load. Okay. Whenever you want, you have to give a power supply. And then one interruptible, non-schedulable load. They are the temperature control loads. Okay, they fall in this category. And schedulable loads. And I want you to pay attention. This schedulable load plays a significant role in the energy management strategies. Okay, they are the ones who are playing with your schedulable load so that your energy bills will be reduced. You will shift from one interval to another interval. Your energy bills will drastically reduce. So if you want to know more how they are classified, I invite you to do this. Okay, now what is this ABC? I told you it is a simple ABC demand response cycle. How this works is very simple. You are having different household appliances. We have classified them in category A, B, C, D. Now which one to turn on first? It depends on you. Now you need to design the priority of each group. So we will introduce priority for each category of the load. Critical loads will be given high priority, and you want to turn on. But low priority loads will be having low priority so that we can shift from one unit to another. So this is the simple algorithm to reduce your energy consumption. So utility is saying that if you consume more than certain units, you will be penalized. How consumer is responding is what the demand response. Understood? This is the simplest. See, I want to repeat this because we will be having a lab session in the second half. Now that we will be having a tutorial. I have designed a simple tutorial one example I will give you. So if you are having these videos, if you consume more than this, you will be penalized with this. Below the penalty, this is the cost. Above MDL, this is the cost. So I want you to write the number to find what is your energy bill at the end of the day. So if you are having any doubts, please let me know. It's simple formula to calculate energy. Understood? Yes, please.
During weekend,
During?
we impose a penalty for Saturday.
So that is designed by the utility. We don't have any control. Where consumers will know only what is MDL price. Okay, what is the maximum?
They impose a penalty to use a loader for 6 to 8 time. Then we have a rooftop. If we generate it, we utilize it, then pricing will be same.
See, very simple. Now they are prosuming. Okay, so this will be reduced automatically for you. And you will be, you will not be penalized. You will not be penalized. You are having a solar and wind, you are using it for your own purpose, so that you can escape from the penalty.
So this is when one utilize our renewable energy during peak time.
And obviously, it is
What is generated given to the grid.
see,
Which is the better.
it all depends upon how much price they are paying. I will come to that. Okay, let's say very simple. It is always better if you use for your own purpose. Let's say still you are having excess. Now you don't have any choice, you have to give it to the grid. But grid will not give you the same price. Whatever you are buying, let's say you are buying from the grid, 1 unit you are buying, let's say it is 5 rupees. Now you are having 1 unit excess. If you give it to the grid, grid will not give you 5 rupees. Grid will only give you 1 rupee.
If price variation we generate our during peak time.
That is decided by the utility. See, utility can design any algorithm. In order to manage this demand and generation, they can come up with any idea.
In real time, if you generate the total power anytime, the unit cost is same.
No, it is different. It is different. So that is decided by the utility. Distribution network operator can design whatever the way he wants to design. I had the privilege to visit one smart grid project in Pondicherry. What they are doing is, so it is completely run by NTPC and BHPL and Power Grid Corporation and Indian Smart Grid Forum and a Chinese government. What they are doing is they have selected a locality in the Pondicherry city. Okay, so they have installed smart meters in 200 to 500 residential homes. Now what they are doing is, it's a pilot project. See, here I am having 10 demand response algorithm. 10 demand response algorithm. Now consumer has a choice. Which one you want to select? It's up to you. I don't want to select anything. I am happy with the flat rate. Whatever the amount I want to consume, I can consume. Okay, so you will be paying accordingly. Let's say now you are having a solar, but you are using it for your own purpose, so that you can reduce your grid errors. Let's say now you are having excess. Your solar and wind capacity is low. You are having excess energy. Now what do you do? There are n number of algorithms. You can pick up which one you want. If they are implementing it, if you get a chance, please visit that. I have visited during 2018. I don't know maybe they have increased their capacity also. It is a pilot project. It is still going on. This demand response algorithms are implemented in many states in the northern India, but in South India, I don't know. I never heard the Andhra Pradesh government is coming up with the demand response. But the northern states, especially Delhi NCR recently, they are using. See, we are using mobile. At the end of the month, we are paying more than the energy cost. But then our energy cost is less. If you consume more data, you will be paying more than your energy bill. Why you should, utility should give you what a subsidy price. If they think, okay, I agree with you, very soon it will happen. Are waste fellow, you are consuming a lot of energy to the EV cars. I will be penalizing you. Then I will come up with a different strategy. I will come up with a time of pay rise. So that your energy consumption cost will vary. From respect to time it will vary. And if you go beyond certain value, I will penalize you. So it is beneficial for both the parties. But in a country like India, we don't accept the change immediately. If we go with this, let's say we go with this, I don't care about the penalty tax. I will simply consume. I will turn on the AC or fan. I will simply move on. I will be thinking that okay, my energy bill will be little less. But if the utility is not implementing this, your energy bill will be more than your income. Okay, so utility can design their own energy management strategies.
Can we treat the electric vehicle apart from solar and wind? Even electric vehicle?
Yeah, consumer, I think I forgot to mention, consumer can have an EV. Whenever the price is low, during the peak time, you can push your energy to the grid. You will be getting some money. Okay, or you can, give your energy from EV to another EV. So too much research is going on, and in the real time, many people are implementing. I have seen in India, people are, they are 10 years ahead of us. Okay, so I hope this algorithm is clear to you. It's a simple ABC algorithm. So this is one of the energy management strategy. And I invite you to read if you want to know more about this ABC demand response algorithm. Read this one. So look, I want to explain that algorithm with some simple case study. A consumer is there. We have taken the data from the residential locality of an individual. So his enhanced load is this. And this consumption pattern of IMS will notice this. They are the critical loads, they are the international control loads. Okay, if you want more how they are, you can go to this. Okay, and these are the results of after implementing the demand response, before implementing the demand response. If you see here, this is without any demand response. This is the load curve of the consumer. Utility is saying that if you consume more than 4 units, you will be penalized. But this curve is not designed. Because he is consuming according to his behavior. He will be penalized for this energy consumption. Okay. So if you implement the demand response algorithm, you see his demand consumption profile. He is always below the MDL or MCL. Even with the this is not throughout the day MCL is fixed. What if you can say that this hour you should not consume more than this? This hour you should not consume more than this. If it changes with respect to time, still your algorithm is working effectively. So now the consumer is behaving properly. You can see this is the simplest energy management strategy. Controlling the consumer so that his energy consumption will be reduced. At the same time, the peak demand in the system is also reduced. You see here, peak demand is there in the system, peak demand is there in the system. If every consumer is like this, the demand of the system is very, very high. It is very difficult to generate or meet this demand. Now the consumer is the proactive consumer is responding to the utility action and his energy bill will automatically reduce. He is escaping from the phenomenon. This is one of the simple case study that we have. If you want to read more about it, I am need to read. So now we are moving to another demand response algorithm. So in order to implement any number of demand response algorithm, you should have an infrastructure at your home. The home system should respond for different algorithms. Just like our mobile phone. I am happy with the AirTag. Next month I am not happy with the AirTag. I can switch to BSNL. I can switch to Vodafone Idea. Or I can switch to some other company. It is a portability. So you imagine in a home, you are having an intelligent energy management system. That takes care of, I can switch from one algorithm to another. I am not happy with the demand response. I am not happy with this. I can switch. This, even you can switch with the companies also. I told you one example. In Ireland, I was switching my distribution company. I changed to 3 companies in 3 months. It's as simple as mobile phone. Okay, so you should have an infrastructure. So what is that infrastructure? This is an infrastructure within the home. You should have an intelligent home energy management system that effectively manage your load. So this person he called as intelligent residential load management system. Basically, it is a home energy management system. What it does is it effectively changes the energy consumption interval of schedulable load so that you will be avoiding the penalty so that you can reduce your energy bills. This system can adopt any demand response algorithm. This system can intelligently choose which one you want for your energy consumption. It is not that you want it changed. The system itself is intelligent to select which one you want according to your consumption behavior. If you are having such a plan, okay, how you can design your algorithm? Okay, so this is the simple flow chart for different demand response. So this system can effectively switch from one demand response algorithm to another demand response. So if you want more about this, there's a paper you can read about. So what this paper is all about is comparing 3 different demand response algorithms, and he is you can see here. I don't think you can get anything from this study or from this paper. And let's simplify this. NSJ means no scheduling algorithm. You are not at all scheduling your schedulable load. Your consumption behavior is up to you. You are not at all bothering about the utility actions. You are simply consuming energy whenever you want. In that scenario, what is your energy consumption? This is priority based demand response algorithm. You are prioritizing your loads according to your priority, and with respect to the utility action, you are responding. This is another demand response algorithm, and this is the demand profile. And this is optimization based demand response algorithm. What is this optimization? So basically, we are optimizing the cost. What is the cost? Energy multiplied by the price. That is varying with respect to time. Price is varying, your energy consumption is varying. We are trying to optimize. You can use any, stochastic or non-stochastic algorithm to optimize. So we use one of the algorithm theoretical algorithm we use, and he is just comparing the different, demand response profile using NSA and PSC. If you want to study more, read this paper. So we can observe here, if you go with different algorithm, what do you achieve? You can see here, for a month, in a year, if MDL is, MCL is this much, with NSA, this is your bill, this is your bill and reduction. You can clearly see that in a year, they are going to reduce your bill. You go with the PC. And if you go with the OSD, this is your reduction in the energy. Okay? And you can see this is an impact of non-schedulable loads. So while scheduling your schedulable loads, you have to consider the non-schedulable loads also. It is not that whenever you want you can consume. You have to consider the dynamics of non-schedulable loads. In that scenario, what is your electricity bill in a day or in a night? If you want to take more, it is. So next one is this I have proposed. This is another simplest ABC demand response algorithm. If your residential locality, they are all consumers, yet they want to participate in demand response. Okay, so there is an operator, network operator, distribution network operator, and the utility is there, and there is a distribution transformer that provides the power supply to the network. Okay, listen carefully. Here onwards, I will be going to using the topics cumulatively. Okay, there is a community where there are only consumers. There are no consumers. Only consumers are there. They wanted to participate in demand response algorithm. Individually they can participate. Collaboratively they can participate. This collaborative based that I have proposed to be and others. Okay, if the residential locality is like this, how we can propose the different algorithm. Okay, so here the stakeholders are operator and the consumers. Okay, I have already told you.
They will also follow another.
Sorry, one other. I will explain how collaboratively they consume energy. This is an optimization problem. Here, in this demand response algorithm, your energy consumption bill is not only due to your energy consumption factor. It is also due to the energy consumption factor of another factor. We are using the conceptual game theory. I hope you heard about the game theory. Okay, conceptual operator game theory, non-operator. It is not something new. It is there from ages. Okay, I'm using the film called Beautiful Mind. My English name from English film is there. Proper actor or Oscar. Very recently it was remade in Hindi by Lansing Channel. Movie name is Lansing Channel. It was a remake of Beautiful Mind. This is a story about a scientist called John Nash, who is the pioneer and who invented this game. See, it is basically, I will tell you a simple sense. What is game theory? Basically, game theory is all about mathematical modeling of, sorry. I will, okay, just give it 2 minutes. So we are using the conceptual game theory. See, our energy bill is not only due to our energy consumption, it is also depending on the other consumption. Okay, so we have design something. So we have a qualification. Okay, I am also part of it. Okay, so if you want to read more about it, I will quickly one. Okay, this is the constraints of documentation form. And this is the center. Do you want me to start from here or shall I find out?
Actually, the thing is,
we want to do that how actually how to write the objective function in MATLAB. That is what we are studying because uh, we are working on optimization techniques. We are finding lots of difficulties in writing the objective function. Many program partners are really used to it. So I will give you a solution, sir. Anyway, you are in your research, first difficulty is finding the objective functions and framing your concept. And which optimization you should select for your problem. So that itself is a very big task and you have to figure out it. For this, you have to do a lot of mathematics and economics. Okay, if you open any literature, there will be n number of ways they will frame the objective function. And if you see the recent article from China, the whole topic is about objective function and concept. Nowadays, the Chinese people in the entire world, Indians and Chinese are very good at maths. But the Chinese are a bit far ahead of us. You see the papers from the Chinese, their mathematics is so strong. For the same problem, they will come up with a unit. For the same problem, they will come up with a graph. For the same problem, they will come up with something else. And they will frame the very big objective function which we can understand. Only that are the somehow they are publishing it. And we are facing difficulty in framing the objective and concept. See, we are definitely making one day that it is not easy. I can give an advice that you read mathematics, applied mathematics, especially the applied mathematics. And then you find an algorithm. Every month new algorithm is coming. You can select any algorithm, whether it is AI based or not based or deep learning based. So many algorithms are coming. So I cannot tell you that this is how it's going. With respect to energy, I can pass. You can contact me. Okay, sir, I will wonder this quickly. Okay, so I am a mathematical study and these are the results of the demand. Okay, and at the end, each and every consumer is getting benefit within the presidential program. So if you want more information, read that paper. Okay, these are the references. Thank you. Any doubts? So I think I have introduced three different dimensions. Is it really eventually feasible? Yes, it is. Outside world, they are operating. Yes, it is. Only the thing is, we need to have infrastructure. Right now, we don't have infrastructure. See, I took a lot of time using the different components of smart grid. We need to have a smart grid. We need to have air conditioning. We need to have a data center. We need to have an infrastructure. If you see the Western world, how they will construct the locality, they will design in advance. In future, the consumer should, the locality should be self-sustainable. They should not depend on the grid. The community should produce the energy so that the demand is met by the whole. That's how they design. They have a very beautiful infrastructure, but we don't have that. See, how we will build a house. I can form my own room. I can drive the people and I can build. I can do it, but then how can we? They work at it.
What about the security aspect of
Yeah, the security is another issue. Recently, you heard about blockchain. It's a digital technology called blockchain. With the blockchain, we can provide, unhampered data. Blockchain is this help to talking about that. With the blockchain, we can provide.
technologies of information is being observed by the
Because that reason, they have designed another technology called blockchain. The technology you have data set. I think you heard about that. Okay, so Bitcoin is a problem. Cryptographically they are linked. Blockchains are they have blocks, they are cryptographically linked. Encryption is there. Our email is also linked. That's something we can do. So now they work in blockchain. They are not secure. You can do PhD on this. And you MS on your affiliation. You can do PhD in the blockchain. That's about your students are working, especially the data section. How we can provide the security in the small. That will be your 2G pieces of 8G pieces of PHP. So shall we write or any doubt? Can I have any doubt? No. I think I have covered a few different demand response already. After this, I will be discussing about another topic that is especially only one publication format. Then the browser is mentioned that I have a PowerPoint. So after the section, we will be discussing about one method.
This doesn't have a voice.
Yes, sir.